Hello, today I will tell you how to process seismic research data which has been obtained by means of ZETLAB digital geophones in the software developed by ZETLAB and RadExPro. As a source data we shall use SEGY-file containing information from 7 seismic SPS and the data received from ZET7155 digital geophones. The mobile system consists of offline recorder ZET7173 and additional seismic survey modules. The measurements were performed in 7 SPS. The distance between measuring modules was 15 meters. There were 8 sensors. And the seismic streamer was shifted at the distance of 15 meters. So, the first thing to do is to download the data from the system to the PC. To do that, we should start ZETLAB software and connect the mobile system to the PC. As you can see, the recorder is recognized as a removable device, and ZETLAB software also detects it. To download the files, you can use Apply key. However, since the data was recorded at sampling frequency of 200 Hz, we will have to change the sampling frequency value to a higher one. For instance, to 1000 Hz. We select the sampling frequency change option, enter the value and click Apply key. Here we can see data conversion process. Data conversion process is performed in Trends view mode. So finally we shall have Trends records file. In addition to signals, the mobile system also records events and seismic excitations at the SPS. And the seismic excitations are caused by input hammer. The input hammer causes activation of the electrical contact, and the digital module integrated into the system records the event. Using the event time tags, we will be able to detect corresponding impacts as well as to detect corresponding diagram area for further analysis. Signal processing is performed using MASW method. So we try to cause surface wave at the SP area. And the wave is then sequentially registered by the seismic streamer sensors. Since the sensors are located at different distance from the shot point, the time delay in the event detection is different as well. That is the very essence of this method, which will be further explained when we study RadExPro software operation. Here we also have MASW manual provided by the software developer company. We are going to implement all the instructions listed in the present manual. Everything is quite simple. We will skip some of the steps that are irrelevant for our case. However, we will highlight the main points of signal processing in RadExPro program. On our PC we have latest RadExPro software version from the official website and the license key connected to the PC. The license key allows us to use the software. So, as our data is ready, we will start working in RadExPro software. The data transfer is almost complete. You have to wait for a while. We have activated sampling frequency change option. That is why it takes some more time to transfer the data. As the conversion is over, the program will offer us to enter Trends View section. We'll do it soon. So, files conversion is complete. Mobile system files transfer is over. Let's start viewing signals. Let's connect our Seismic station to the PC. Here is the list of the signals downloaded from our mobile system. In the notebook I have impacts time records. Measurements in the first SP started at 2:23 p.m. It also took some time to install the sensors. So we'll request data for the first SP since 2:20 till 2:35 p.m. So to do that, click Select Signal key. We need signals from geophones, so we have to remove irrelevant signals from the list. We remove irrelevant signals from the list. Here you can see 8 signals from geophones. In this section we set date and time parameters to 20 to 35 p.m. Then we click Apply key. So here you can see all the signals for the selected time period. In the first section you can see events relating to a digital geophones installation. So during installation we were working near the geophones, so you can see the signals here. So in this section you can see the excitation at the first SP, the first 5 impacts. There were 5 impacts at each SP. At the SP number 6 there have been 7 or 8 impacts. So we select the first impact. Before we proceed with the first signal, please note that the bottom section of the program depicts all the events registered by mobile system digital channel. This precise time text will allow us to select signals for further processing. Let's get closer to the first impact. To select the event we have to find the impact, find the time tag 2:31 p.m. Now we have to find the time tag among registered events. So here it is. After double clicks, the program sets the time section of the event and depicts 60 seconds of signals records before and after the event. So the signal is found. Now we have to save it as a SEGY file. To do that, you can right-click the event and select Save Event Signal. Time tag is set automatically, so that the event duration will be 1 second. That is enough for MASW processing. So the sampling frequency is 8000 Hz, so we'll have 8000 points. Click Continue, select SEGY file type, enter location for saving the file, and name the file Impact1. The file has been saved. The program shows its location. Then we save the remaining 5 impacts in similar way. Time tag for a second impact is 2:31:34 p.m. Select and save it. Then the third impact. Time tag is 2:31:43. Then the first impact. Time tag is 2:31:58 p.m. And the last impact, number 5, time tag 2:32:06 p.m. And this is the following event after the impact. Yes, that's it. Now, in the section Seismic Survey, we have PS1 folder with all the 5 impacts. The next step is to save impact files for the remaining SP points. So the Seismic Survey section has folder with impacts data for each PS. One SP has 8 impact files. The next task is to obtain impact average values for each SP. That is to merge 5 impacts into a single one. Before doing that, it is recommended to use SEGY-file to review impacts data. For that, one can use ZETLAB Results View software. So we can drag the saved file, for instance, impact1, to the program window. The program shows impact diagram. Let me change the brightness. Now you can clearly see how the wave was gradually reaching each of 8 sensors. So the same option is available for all impacts. We will consider only the first one. Now, as I have already said, we have to average the impacts data and to merge them into a single one. To do that, we activate SEGY Converter program. It allows to average and merge SEGY files. To average first SP impacts, we use Add key. Open the folder with first SP impacts values, copy them, and add them to the list. After that, we can click Average key. Then we exit the folder and create a file, point1, to save the average data. Click Save. So click Save, and now we actually have a new file in the folder. Point 1. It contains average input values for the first SP. Then we have to perform similar steps for all the remaining short points. We have done that beforehand to save you time. And the last thing to do with the signals received from each short point is to merge them into a single file for further processing in RadExPro software. To do that, we have to clear the list of files in the SEGY-file converter window and then add the averaged values to the list. So finally there should be 8 files corresponding for each of the short points. So we can see them in the list here. Now we select Merge option. It will be activated for all files. The resulting file will be called Final File. Select Save option. We have updated the file. Now it contains a set of inputs for each of the short points and for each of 8 digital geophones. Let's check the file while dragging it into Results View program window, which we have already used. Now we adjust the brightness so you can see all 7 short points with signals from 8 digital earphones. So we will not use Trends View and SEGY Converter programs anymore. Now we have all necessary data for further processing in RadExPro signal processing program. Let's start. In accordance with the requirements specified in the manual, we have prepared a test project, test MASW. The project already contains necessary modules listed in the manual. We will consider these modules and their functions in more details a little bit later. Now we select already existing project. As prescribed by the manual, we have created 2 flows. Flow 1 is for data preparation and for further processing in MASW module. It contains source data module, sensor layout module, it also has output data module and a SEGY-file view module. Let's study the first module. We have to put the file to be processed in the first module. In our case it is final file, which we have previously created. We should add it to the module. Here it is. The program depicts sample interval corresponding to sampling frequency of 8 kHz. Number of traces 56. It corresponds to 7 short points with 8 sensors per each. Trace length 8000. This value corresponds to the frequency value and the points number. The data will be saved in IBM floating point format. These are all the options that we need in this module. Now we enter the near surface geometry input. The manual says that this module allows to change the geometry parameters of the loaded file. So let's do it. Double click the module to activate it. Let's choose variable option and set the parameters below. First source position stands for the location of the first shot point. First receiver position 10 meters. It means that the first sensor, the geophone, was placed at a distance of 3 meters from the shot point. Source step 15 meters. It stands for shifting the seismic streamer by 15 meters at each shot point change. Receiver step 15 meters. This value means the distance between digital geophones, number of channels. In our case we have 8 channels. The remaining parameters have default values. So we have set geometry parameters beforehand. As for trace output module, we have just set the file to which the data will be saved. It has been done in full compliance with the manual without any additional steps. And the screen display module. Here we set number of traces value 56, which corresponds to our SEGY-file. After having set all these parameters, we can start this flow. So what we can see now is quite similar to the diagram from ZETLAB SEGY-file view program. Here we can see data from 7 shot points, having 8 channels each. The seismic wave achieves each consecutive geophone with certain delay. As this flow has already prepared the data we need for MASW analysis. Now let's study flow number 2. As prescribed by the manual, it contains only MASW module. This module settings are set by default. There are no other parameters to be set in the module. Let's start this module. So now we can see the MASW manager window. The first thing to do is to start dispersion imaging. Now we select calculate from data option. Here we can select data from which the dispersion image will be formed. Following the manual, we select the data saved by flow 1. So as the data is selected, click OK. As we can see, MASW module has created a dispersion image based on the source data of our file. It should also be noted that since we have several shot points, the dispersion image was automatically created for each of the shot points. The next step is to select oscillations modules. The manual describes basic and first upper oscillations mode. Actually, we can do it since we clearly see the first and the upper oscillations mode. Now we have fundamental mode. It stands for the upper mode. Let's highlight it on the diagram. So what we can see now is a kind of a curve. This curve represents averaged peaked values. To improve the representation of the curve, we can use this key in the menu. So, a few clicks on it and enough. The same procedure is applicable for the first oscillation mode. We select the points and click this key. We have just made two curves for the first dispersion image. Now we can do the same for the dispersion image of the next shot point. So we have created these curves for all the dispersion images. Now we are going to use them for further inversion processing. So to do this, we have to click this key and enter MASW Manager window. We can see that all the recent curves are added to the list. Now the inversion key is active. So now we can set inversion parameters. Number of layers 5, will not change the value. Half space depth 30 meters. Density and Poisson ratio parameters won't be changed. Number of iterations parameter for the inversion, we will set 10, click OK. What we can see now is a diagram of velocity distribution based on depth parameters. In order to receive final data processing result, we have to set the parameters for each shot point using inversion. Double-click the shot point, click theoretical curve key. To align the curves, we have to use Run Inversion option. There will be several iterations. As we can see now, the curves almost merged. After that, we can click Apply key. So the parameters that we have just set are now applied to the first shot point. If you want to set the same parameters for the remaining shot points, right-click the first one and choose the option Spread this module to all shot points. This will allow us to set the same parameters for the remaining shot points. The image now looks like this. Now, according to the manual, we should start the inversion. We choose the option Run Inversion for all the shot points. As the inversion for all the shot points is complete, we can see a realistic representation of velocity distribution by depth. So the data received is suitable for the purpose of further analysis and seismic research. The data received is suitable for the purpose of further analysis and seismic research. So thank you.